So, when it comes to the currents, if you want to measure the current, we use a device called ammeter, and to measure the voltage, we use an instrument called voltmeter. Now, if you take like ammeters and voltmeter, now actually there are two types of ammeters and voltmeters available right now. If you take these kind of ones, these are like analog ones, right? So then, whatever the circuits you can see here, there is a red and blue terminals are there, right? So then using them, right, so we can connect this ammeter into a circuit. So then from this scale we can take the readings, right? Now for you can see there are two red knobs are there, right? So then one of them used for like a smaller currents. As you can see, there's a small scale which goes like 0, 0.2, 0.4, like that. So the other one is used for larger currents, such up to like 5 amperes, right? So in that case you can connect the currents, the whatever the circuits, the terminals into this other red terminal, right? So and the negative wire is connected to the negative terminal of the battery as well. Okay, so then this is the ammeter, right? So then now we have actually now we nowadays we have like digital ammeters as well, right? So then it's more easy to read, take a read from this device, right? Now similar to that we have the voltmeters as well, right? Whether it's a voltmeter or the ammeter, it looks the same, right? Only difference is the way how they work, right? uh, Same way, right? So then this is the voltmeter. Analog. Right. So then analog voltmeters and ammeters, if you consider the look, the appearance wise, they both are the same, right? So then from this scale, you can take the readings if it is a if you are using an analog voltmeter or ammeter, right? If you are using a digital one, from the screen you can directly see the scales or the readings, right? Now if you come to that voltmeter ammeter, right? Now there is a circuit symbol. For ammeter we use the circuit symbol like this. For voltmeters we use the circuit symbol like this. Simply it's the voltmeter is the circle with the V, the ammeter is the circle with the A, right? So then if you want to connect it, you can use this kind of connection wires to draw it with the circuit, right? And most importantly, what you have to know is, right, so how are they connected, right? Now ammeters always connected in series with whatever the circuit we are circuit components that we are using it with, right? And the voltmeters, they are always connected in parallel, right? Now for example, let's say we have a circuit. Let's say we have R1, R2, R3. Right? So then there are three different resistors are connected with the circuit, right? So then if you want to measure the current of this R1 and R2 resistors, now you know R1 and R2 are connected in series, so therefore they both have the same current. In this case, if you want to measure the current in them, so what you have to do is you have to connect the ammeter in series with them, right? So then this one is measuring the current of R1 and R2 only. So then if you want to measure the current in this other one, that means R3, so then sorry, you need to connect a resistor, sorry, the ammeter in series with that one, like that, right? So then let's say you want to measure the total current in the circuit, so then in that case you can connect an ammeter somewhere there, right? Now we have three ammeters, 1, 2 and 3. So then the ammeter 1, it measures the total current. Why does it measures the total current? You can see the current come from this point, so it will be divided into the through this junction, so I1 and I2. So then once it comes back to the other junction here, so then the currents will be joined together and the total current once again passes through this circuit, right? So therefore wherever the total, whatever the current passes through the ammeter, it measures that current. So then if you want to measure the total current, you have to connect it along that path where the total current is flowing through, right? So then if you consider ammeter 2, it measures the current in R1 and R2 only. Why? Because it is connected in series with that path. So then the current comes through the R1 and R2, passes through the ammeter 2. And ammeter 3, That one is measuring the current only in R3 current only, right? So then whatever the current through the R3 is measured by the ammeter 3, right? This is so then the same way we can connect voltmeters to this circuit, right? If we remove this part, right? Now if you want to measure the voltage across any component, right, what you have to do is you have to connect the voltmeter in parallel. So voltmeters are always connected in parallel with the circuit components where you want to measure its voltage. Now, for example, if you want to measure the voltage across R3, so then you have to connect the voltmeter across it, right? Parallel to the circuit like this. So then if you want to measure the voltage of R1, so you can connect the voltmeter like this. So then this voltmeter, if you take it as 1, so the voltmeter 1 is measuring only the voltage across R1. So then if you want to measure the voltage only across the R2, so then you have to connect a voltmeter across that one only. So then the R3 will measure the voltage across this one, so the R3 resistor. But you can see, since the R3 is connected through parallel to the battery, as it also measures the R3's voltage, right? And also it measures the total voltage supplied by the battery. Why? Because you can see the R3 is directly connected parallel to the battery, so therefore the voltage reading is always same, right? Is it under? Right. Now the first question, right? So then, what is this device? So it's a thermistor, right? So we discussed about the thermistor before as well. Thermistor means it has its resistance decreases when the temperature is increases, right? Now that's why it's in the next question. It's given at 25 Celsius. Specifically, it's given. So then the voltage across the X is 4.5. So then the voltage here is given as 4.5. Calculate the voltmeter reading. Now you can see, since the voltmeter is connected across the Y, so that means it is measuring the voltage across this Y. And we know the X and Y are connected in series, so therefore their sum of the voltage should be equal to the supply voltage. So then 4.5 plus V, right? Resistance of Y is 200 ohms. Calculate the reading on the ammeter at 25 Celsius. So then reading on the ammeter means we have to calculate the current, right? Again, you can see, since it's a series circuit, so everywhere the current will be the same. So then if we apply the V equals IR only to the resistor Y, so then we know the voltage across the resistor is 1.5. uh, Current is what we are trying to find out. So then the resistance is 200. So then current is equal to, it's 1.5 divided by 200, that means 0.0075 amperes, right? Or else we can divide this by 1000 and say 7.5 milliamperes. So 0.0075 amperes, so 7.5 milliamperes, either way you can say, right? And the next one, uh, okay, calculate the current in the X. Actually, this should be I wrote it incorrectly. It should have been resistance. Why? Because no point of calculating the current again, because the current in X and Y both are same, right? So therefore, if we apply V equals IR to resistor X, so then what happens? Now we are doing the answer to this one, part 4. So then voltage across it, we already know it is as 4.5. So then we just found out the current as 0.0075 times the resistance, right? So then should get R as 600 ohms, right? The last one says the temperature of the X is increased. Explain what happens to the voltmeter reading. I shall erase this one. right? Now if the temperature, okay, first I'll erase the other values as well, right? Now we just said in a thermistor when the temperature is increased, what happens is the resistance is decreased. So that means in the circuit the resistance is decreasing, right? So you can start with that. When temperature is increased, the resistance of thermistor is going to be decreased, right? Write properly, right? Don't write arrows when you're writing the answers. So if the resistance is decreasing, that means the total resistance of the current is decreasing. So then we know the equation V equals IR. So then the supply voltage, the battery is supplying the constant voltage. If the resistance is less, now we have higher amount of current. Okay. So then current in the circuit increases, right? So then if you apply V equals IR to that resist the Y to Y, right? Now previous we applied to the whole circuit, now we apply to Y only. So then if we can increase the uh, sorry now the resistance of that one is remaining at 200. So then by somehow then the current is increased means the voltage across that resistor is going to be increased as well. So that means when the current is increasing, the voltmeter reading should be increased, right? Is it understood or no? uh, when the temperature increases, the resistance of the thermistor decreases. When current in the circuit, then the current in the circuit decreases. Why? Because the total resistance is also going to be decreasing, right? So we erase this part. Yeah. When then the current is increasing when the total resistance is decreasing. So then if we apply V equals IR to Y, right? So R is constant, right? So therefore when current increases, the voltage is also going to be increased. Now this part is not just necessary to mention, right? So if you just say that when the current is increased, the voltage reading is also going to be increased, so that means the voltmeter reading is going to be increasing. So then that is enough, right? So then these three steps, simple steps, are enough to write the answers to the last part. Okay, right. Okay, so the next part of the lesson is called the mains electricity. Now, what is meant by the mains electricity is this is talking about the how the electricity is supplied to our houses or whatever the buildings, right? Now, when it comes to the houses, right, so the electricity is coming from the electricity board, right? So you know that electricity board in different countries, I don't know, maybe different private companies can be there, right? So in Sri Lanka we are getting the electricity from the electricity board, right? Actually there's another private company as well. So then either way it's coming from them, right? So when the current reaches our house, right, so it is coming from a special line called the live wire, right? Actually there are two wires are coming from the electricity board. One is known as the live wire. I use this yellow lead, right? So live wire. So then the other one is known as the neutral wire, right? Live and the neutral, right? Actually, the current is coming to the house through this neutral wire. Sorry, the current is coming to our house by this live wire. So then after it's passing through whatever the devices, so then to complete the circuit, so it will be going back to the electricity board through the neutral wire. Okay, so then first it will measure, it will pass through something called an electricity meter, right? Okay, so then first it will pass through an electricity meter, electric meter, right? So then it passes through the main switch and the trip switches from main switch. So then it will go through something called circuit breakers, where we have the trip switch and circuit breakers, right? Circuit breakers. So then the live wire and the neutral wire, both they passes through these circuits. Understood? Right. So then what does the electric meter do is, right? Yeah, so then electric meter does is, right, so it measures how much electricity we are using in our house. So then it is measure the energy, how much electrical energy is using. So then the main switch, trip switches, normally they all are connected in like a one space, right? So then different switches are there, but most probably they will be in the same space, right? So then the main switch, when you turn it off, what will happen, the electricity supply can be disconnected by the main switch. So then the trip switch is a safety device, we'll discuss about that one briefly later. And the circuit breakers, when you say the circuit breakers, so then that is where the supply electricity is divided into different circuits. Now for example, now if there are like upstairs, the kitchen, the living room, right, so the bathrooms, right, so like that, so then different circuits, normally a house has different circuits, right? So then why, because sometimes the kitchen, even though there's some sort of a repair is done in the front room, the living room, or the upstairs, the kitchen must be supplied with electricity to do whatever the cooking, right? So therefore two different circuits can be used there, right? And also, right, most importantly, right, so there are some electrical devices which needed like different amounts current, right? So some devices use 12 amperes current, some devices use like 5 amperes current, some devices use like 15 amperes current, right? Now if you may have seen in your houses also, there are some plug points are there with larger sockets. So then those plug points are somewhat bigger. So that is because they are using a large amount of currents compared to the other ones. So especially like if you have like a hot water shower, right, or like a hot plates, right, so they are connected to high electrical supply because they require higher electrical energy. So then to those different circuits, the current is circuits are divided by this circuit breaker, right? So then once the current reaches this circuit breaker, right, so then for a given section it will create this kind of a ring, right? So then the two rings will be created like this using the live wire and the neutral wire both, right? So then whenever you are, if you want to connect a device, so then that's where you have those plug points, right? So then the plug point, one of them is connected to this neutral wire, so then the another one is connected to this live wire, right? So then when you connect a device into this one, right, so whatever the device connected, so then the current is coming from the live wire through all of those circuits, and this through this ring circuit, this is known as the ring circuit, right? So then through this plug point, so then the current is supplied to that device, and after the device, the current is coming back through this blue line, that means the neutral wire, right? So then if you want, you can connect more than one power plugs. Yes. Yeah, yeah. Why I come to that, right? So then this is, now the current is coming to the device and it is leaving the device through this live wire and the neutral wire. That's okay now. Right. So then normally when it comes to the circuit, so then other than in this ring circuit, other than these two wires, right? So we have another wire as well. So then that is what you said, the earth wire, right? So then earth wire is connected to this top pin, right? So why do we have this earth? Why it is a safety device, right? So then it is not bringing or taking out any currents in normal situations, but if there is a problems with the circuit, right, so then there is, or whatever the device you are using, so then that device is, there is some sort of damage, so then the wires are touching the device, so that means the entire electric device can be electrocuted. So if that kind of thing happen, right, so then what will happen, that current, that extra current in that device will be taken out through this earth wire, right? So normally that earth wire is connected to a metal ring. I mean, sorry, not a ring, like a metal rod, which is buried deep in the ground somewhere in your garden, right? So then if you are living in a building, right, so then all the buildings they have this earth wire. So then this earth wire is buried deep in the ground, right? So normally we draw the earthing symbol like this in a circuit, right? So it's connected to a copper rod. So then what will happen, if there is some sort of a problem with the electrical circuit or whatever your device, when current coming from the live wire, if it happens to like a leaked through the device, right? So that means it's not only passing through the circuit components, it's the live wire is open and it is in connected with some of the other metal parts. So in that case what will happen, the entire device may be electrocuted. So that means if a person touches that device, so he gets electric shocked. So then to prevent that thing, so then what will happen, and earth wire is connected, so then that leaked current will be passed through that earth wire into the ground through that earth, the buried, deep buried the road, right? Now also it's sometimes if there is some sort of like a electrical charges were generated due to some reasons in any of those devices, so then those generated charges can be safely removed through that earth wire as well, right? So then it has nothing to do with the electricity board, it is just a safety device. Understood? So then that's what mentioned in your note as well. Source of electricity in our house is called the mains electricity. The current enter our house first pass through the meter that measures the electrical energy we consume in our house, called the electric meter. Then it pass through a fuse box or the consumer unit. So then it contains all fuse and circuit breakers in a circuit. So I didn't mention about the fuse yet, but the circuit breaker I told you, right? So that's where the circuit is divided in different components. I'll come back to the fuse later, right? So then we have the ring main circuit. So then wires that leave the box are hidden in the walls or floors around each room. These wires are connected to form ring main circuits. Individual components are connected to these rings using the plugs. It contains of three wires: live wire, neutral wire, and the earth wire. The live wire provides the path along the electrical energy from the power station travels. The neutral wire completes the circuit, and the earth wire usually has no current in it. It is there to protect you if an appliance develops a fault. It provides a path for a current to escape without passing through the user or the device, right? So then the mains electric supply into homes in many countries is between 220 and 240, right? So then there was a very interesting word was there, right? So the fuse, right? Fuse, right? Now the fuse, the image of the fuse is I have included once again in the note, right? So then, yeah. uh, this device you can see it is what we call as the fuse, right? Now the purpose of the fuse is when the, let's say it's connected to the circuit this way, right? So then the device is whatever the device is there, right? Normally the fuses are connected to the live wire only, right? So then what happens now, due to some error in the power supply or anywhere, right? So if there is a larger current comes to a device, what will happen is this fuse will be melted, right? Now the wire inside, you can see there's a wire inside this fuse. So it is not a normal copper wire, it is a alloy, right? So then where it gets melted if the current is too high, right? We know whenever there's a current in the wire, they gets heated. So then due to that heat, if the current is higher, the heat is also, the temperature is going to be high, the heat is going to be higher. So then that is enough to melt this wire, right? So then let's say we need the whatever our device here, right? So it's only using 5 amperes current, right? Due to some error, maybe due to fault in electricity board or due to a lightning strike or something, right? So there's like a 10 amperes current is coming through this device, right? So then what will happen is, now this fuse is rated like 6 amperes or something like that. So then we need 5 amperes. So then this fuse will not allow currents anything above 6 amperes, right? Now for a device require 5 amperes current, 6 amperes is not a big problem, right? But if that 10 amperes current comes through this device, what will happen is it might damage this device. So that means this device can be burnt. Okay, so whatever the components can be temperature is too high, anyhow the device is going to be damaged. So then what will happen if the 10 amperes current comes through this fuse? So then the fuse wire will be melted, the wire of the fuse will be melted. As a result, what will happen, then the current supply to this device is going to be blocked. So then our device is safe from that higher current, right? So then what do you have to do? So then if once that problem is fixed, all you have to do is just to replace this fuse without replacing the entire instrument or the device. We can just replace this small part for a very small amount of price, right? Now if the device is going to be, if you want to buy the device, so you have to spend thousands, right? So but this fuse is very small part, it only cost you very little amount of money, right? So then it won't be a problem. So then that's why we use these fuses, right? So if there is, that's what mentioned here, so if there is too large a current in the circuit, the fuse wire becomes very hot and it melts. It says the fuse blows, right? So the melting of the fuse, we normally in general terms we call it as the fuse blows. The circuit is now incomplete, so there is no current, right? So then the circuit symbol for the fuse is like this, just like a resistor but a line passing through it, right? Remember the resistor, we just draw it like this, there is no line in the middle, but in the fuse circuit there is a line in the middle, right? So then draw that line, the circuit symbol there in your note as well, right? So then always keep in mind, right? So the fuses are connected to the live wires, and the fuse rating, we call it as the rating. So that means if this is labeled as 6 amperes, so that means 6 amperes is the maximum current that will be allowed through that fuse. So then if anything above that one, the wire will be automatically melted. And here further, right? So a fuse is usually in the form of a cylinder or cartridge which contains a thin piece of wire made from a metal that has a low melting point. The fuse must be placed in the live wire. There are several sizes of fuses such as 3 amperes, 5 amperes, 13 amperes. The correct fuse for the circuit is the one that allows the correct current but blows if the current is little larger. If the correct current in a circuit is 2 amperes, then it should be protected with the 3 ampere fuse. Modern safety devices such as those you might find in your consumer unit are often in the form of trip switches or circuit breakers. If too large a current flows, a circuit switch automatically opens, making the circuit incomplete. Right now, earlier days, right? So then every house has a lot of fuses connected in their houses. If you go back to that circuit diagram, right now, before this current enters the electric meter, there will be a fuse there, right? So even in this trip switch and the circuit breaker, so then each trip switch and the circuit breaker is connected to different fuses, right? So then each circuit, the live wire is passing through each circuit will be divided in passing through the fuse as well, right? Each circuit connected to the different ring circuits, those circuits will be passing through fuses as well. But nowadays, so then these fuses will be replaced by the circuit breaker. It's automatic switch. If the current is too large, the switch automatically turns off using electromagnets. So then how this one is working, we'll be discussing in the magnetism lesson. So then for now, just keep in mind a fuse is a safety device which is used to block any higher amount of currents, right? the next part is about the earth wires and the double insulation. We just discussed about the earth wire. So many appliances have metal case in. This should be connected to the earth wire so that if the live wire becomes damaged or breaks, it and comes into contact with the case in the earth wire provides a low resistance path for the current. Some modern appliances now use, okay, first before that, right? Now let's say we have like a metal iron or something, right? So in iron, right, we have this handle, right? So in the iron, especially this lower part is metal, right? Now nowadays, this rest of the device is covered with plastic, but earlier days, right, so there were a lot of metal parts included in this handle sometimes, right? So then, due to some faultiness, right, so in the device, so if the live wire happen to touch this metal surface there or anywhere else, what will happen, the current will be passed through that metal device. So then earth wire is connected to that metal surface, so then which will take out that current through that earth wire, right? So then live wire provides the current, so then that current in this metal piece will be transferred into the earth wire if there is a force. If there is no fault, no problem, then the current comes in, it will pass through the neutral wire as usual. But if there is a problem, so then the earth wire was necessary, right? But it says some modern appliances now use casings made from an insulator such as plastic rather than from metal. Of if all the electrical parts of an appliances are insulated in this way so that they cannot be touched by the user, the appliance is said to have double insulation. There is no need for the earth wire for these appliances, right? Now you may see it, right? So there are some electrical devices, right, so where there is no three pin plug, right? So some devices there is only two pins are there. Right, so why is that two pins are there? Because the earth wire is not that necessary for those kind of devices. Why? Because the entire device can be covered with plastics where it won't be a problem to whoever uses that device, right? So therefore earth wire is not necessary if you use that kind of plastic casings everywhere. So then that one is known as the double insulation, right? So then next part is about the switches. So then the switches in main circuit should always be placed in the live wire so that when the switch is open, no electrical energy can reach an appliances, right? So especially in the exams, right, so then they are most of the time they are asking about the three types of wires, right? Live, neutral and earth wire, right? So then and also they are always asking about the fuses, the uses of fuses, what is the fuse, and they can ask you about the current required for a fuse. Right now, for example, right, as I was saying, right, so if this device is using 5 amperes current, right, so let's say you have three fuses, 2 amperes, 6 amperes and 10 amperes. So which ampere, which fuse you are going to be using, and why you are not using the others, you can ask, they can ask questions like that. So we know 6 amperes is the most suitable one. Then 2 amperes is not suitable at all. Why? Because anything above 2 amperes the current will be blocked. So then even if 3 amperes come through that one, the fuse will melt and the current will not be able to enter the device. But we need 5 amperes current to work with this device, right? So then we will never be able to use that. But if you use like 10 amperes fuse, what will happen when the 10 amperes comes through this device, so then the device will be damaged. So then since the maximum current allowed by the fuse is 10 amperes, so then it won't be a problem for the fuse, so then the fuse will not be melted. So then the high current enters the device, so then it can cause problems, so like fires or even the internal damages, right? So then therefore 10 amperes is also not going to be suitable because it's too large, right? So then only fuse that is suitable is this 6 ampere fuse.